Okay.
Towards me out, but towards me
Towards the glass. There you go. All right, so Dave, David, next to you there, read the little description, what's going on with the book, or the problem.
Read the entire word problem?
Yeah.
All right. So pinatas are made to sell at a craft fair. It takes 2 hours to make a mini pinata and 3 hours to make a regular size pinata. The owner of the craft booth will make a profit of $12 for each mini pinata sold and $24 for each regular size pinata sold. So if the craft booth owner has no more than 30 hours available to make pinatas and wants to have at least 12 pinatas to sell, how many of each size pinata should he make to maximize his profit? So I started by defining the variables. I just made X the mini pinatas and Y the regular size pinatas. And since it takes 2 hours to make a mini pinata and 3 hours to make a regular size one, that's my first inequality. So 2x plus 3y is less than or equal to 30 since he only has 30 hours to make pinatas. And then my second one is how many he wants to have made at one time. So I just added the two together. And he wants to have at least 12. So I said greater than or equal to 12. So then for the graph, I solved to isolate y. And you get y is greater than or equal to negative x plus 12. And y is less than or equal to negative 2/3 x plus 10. So when you graph those, that's the shaded region right there. And then you take your vertices, which are 6, 6, 12, 0, and 15, 0. And the objective equation is how much money he's going to make for selling each pinata. So he's going to make $12 when he sells a mini pinata and $24 when he sells a regular size pinata. So if you plug in 6, 6 into that equation, you get $216. If you plug 12, 0 into that equation, he will make $144, and if you plug in 15, 0, then he is going to make $180. So to maximize his profit, it would be the best for him to sell 6 mini pinatas and 6 regular pinatas at the craft fair.
Okay, Dave.
So just so that you can, boy, maybe I should have picked on Jake too. Next time.
No.
So just so that you can see a little better, he did an excellent job explaining. So your two inequalities, get them in y equals form, so the y is by itself. And then in this case, you didn't have to count by anything. But I would say, Dave, I'm just going to write on your page. Make sure that you label a couple of them just so that I know that you're just counting by those 1, 2, and then don't forget to label what each represents. So the X is the mini pinatas, the Y represents the large pinatas. After you get your shaded region, the region is in between those two lines. I think this is one of the only problems that we've done where it isn't like down below in this quadrilateral section. And that's because the one inequality is greater than or equal to, the other one is less than or equal to. So you're literally shading between those two diagonal lines because the inequalities are opposite each other. So that is why it's not to this section right here. And greater than this line, less than that one. So it's that little itty bitty triangle, obtuse triangle. So as he said, he plugged in his order pairs. 6 mini, 6 regular are going to get you $216, which is the max profit you can make. Questions? Thank you, Dave. All right, so we're going to look at number 8 as well. So you want to pull this down a little further. There you go.
So,
You good.
okay, so number 8 says a company manufactures 2 types of printers, an inkjet printer and a laser printer. the company can make a total of 60 printers per day, and it has 120 labor hours per day available. It takes 1 labor hour to make an inkjet printer and 3 labor hours to make a laser printer. The profit is $40 per inkjet printer and $60 per laser printer. How many of each type of printer should the company make to maximize its daily profit? So I figured out that I put X as the inkjet printer and Y as the laser printer. My first inequality was X plus Y is less than, right, than 60, which is Y is less than or greater to negative X plus 60, which X plus Y would be the printer's total. It has to be around 60. That's the total it can make per day. Then I have X is greater than 0 and Y is greater than 0 because you want it to be a positive graph, kind of in that second quadrant.
First
I mixed that up, sorry. My other inequality is, I'm going to borrow your pen because this is kind of, just so you can see this better, it's X plus Y is, X plus 3Y is less than or equal to 120, which would be how it takes 3 more labor hours than how it takes 3 more labor hours to make a laser printer than an inkjet printer, which would be Y is less than or greater to negative 1/3 X plus 40. That's my graph. I counted by 5s to make it more visible, not too small. The vertices is 0, 0, 0, 40, 60, 0, and 30, 30. And the object function was P equals 40x plus 60y, which is $40 for the inkjet printer and $60 per laser printer. And when you plug them in, I only plugged in the 3 because 0, 0, you just get a 0 answer. So they would make $0 if they actually made 0 printers of each. If they just made 40 laser printers, they'd make $2,400. If they made just 60 inkjet printers, they would make $400. And if they made 30 of each, they would make $3,000. So maximum profit would be $3,000.
Any questions for Caitlin? Nice job, especially the two of you being put on the spot. Thank you. Very nice. So, I think the common thing from out the day, the profit equation, if it's talking about money and what you're going to earn or the profit of whatever you're selling, that does not go as an inequality because it's how you're earning money, and we're going to use the inequalities to find out how we can earn the max amount of money. So it creates its own objective equation. So anytime you're talking about money, that goes in the objective function. Pretty much very standard. So if I want to earn money by selling something, that's going to be how we'll make the most amount of money, the most profit, or maybe it'll be the least cost that we would have to deal with. Questions? Very nice job, Katie. Are there general questions that you have for the linear programming? So there's 2 inequalities that you have to have almost every single time. X is greater than or equal to 0, Y is greater than or equal to 0. That keeps it in the positive first quadrant, unless it specifically said that we had to make 2 inkjet printers or 2 laser printers, then that number would change. But otherwise, we always have them in every problem, because you can't have a negative amount of a physical object that you're making. So tomorrow you have a quiz. Jake, you did a little shake there. The quiz is on substitution, elimination, graphing 2 equations, finding where they intersect, determining if they're parallel or if they're the same line. And then also graphing two inequalities and just determining the solution where the shading would overlap. Yes, there could be a word problem, but the word problem would not be the huge word problem. It would be more one that you're solving algebraically with substitution, elimination, or graphically, your choice there. There's a take-home portion as well. So the quiz in class tomorrow is 30 points. And I'd say it's not really, it's just front-back. So it's just one page of paper with the two sides. I will have time in class to go answer a couple of questions before you take the quiz. Then there is another assignment, and that other part of the quiz is the take-home portion. And that take-home portion is the linear programming part. That is 20 points, and that's due on Tuesday. So you might be able to start that in class tomorrow. After you hand in your quiz, you probably can start working on that assignment. So today we're going to review some kind of concepts that we've talked about. We're going to start one of the linear programming problems that you have for homework tonight. It's a little more involved, and it's closer to what your take-home will be tomorrow. It has 8 inequalities instead of just 4. So your take-home is going to be somewhere in the middle between the 4 that you had on today's 2 assignments and those 8. So it won't be as crazy as the 8, but it definitely is going to be more than 4. So I have 2 worksheets to hand you up to you for that, and then I have a review worksheet that reviews substitution, elimination, and just graphing 2 lines and finding where they intersect. The other part that's on your assignment sheet, not on the board over there, is totally optional. So I'm not expecting you to do that. You don't have to have it done and complete for tomorrow, but if you feel like you need extra practice on substitution, elimination, graphing equations, or graphing inequalities, those problems are in the book for you. And you actually could do all of them, 1 through 13 if you wanted. I just have 5 to 13 odd, just so that you have a couple that you can kind of work on. But totally up to you. So there's no expectation of you to do those. So just make sure you're noting that to yourself. You don't have to do the book work. I have 3 worksheets for you to work on as a review. You don't need to do the book work. So I have some things to pass out. Unfortunately, when I was making these, I made them as 3 separate documents, and I wasn't really thinking that I should have them all together. So they're 3 separate pages that we will staple together, and it'll form a review packet of sorts. I'll tell you how to staple them together in a minute, but so you're getting 3 pieces of paper passed out to you. Jacob, you're the friend. Sorry. I will quickly meet there. Here, you pass these out. So Jacob, if you don't mind counting either 4 or 5, depending on how many's in a row, passing them out to everybody. And then which one's second?
My accuracy is
Good job counting.
Wait, what order?
All right, so I'm going to show you the order. This one here is first. So the one that has it's like a little review of the 3 ways to solve a set of equations, a system of equations. So this should be first. It's just single-sided, it doesn't have a back. And then there's worksheet 1, followed by worksheet 2. So the one that goes front is like the review of substitution, elimination, and graphing system. Yes, and that's the one we're going to start together. The last one should be the vitamin problem, and we're going to start that one together. The stapler is coming around. This first page, there's one problem at the top here that you're going to solve 3 different ways as a review. So So when you graph it, you either need to get the equation in y equals form, or you need to show your work as to what you're using for the x and the y intercepts. Oh, it's an extra. And then you're going to take that same equation and solve it with substitution, and then you're going to take the same system and solve it with elimination. If you don't get the same answer 3 times, then you made a mistake somewhere. Because if you're solving the same system, you should be able to solve it graphing, substitution, or elimination and get the same exact answer all 3 times. So that's the first page. The second page, I would say, is an average problem. Probably similar to like you had yesterday in your homework. The third page, the vitamin problem, is a good problem. It's a good one. So we're going to start with that one.
We have to do all these for tomorrow?
Yeah, but you're going to have a lot of time to get a good start. Alright, so let's look at the vitamin problem. We're going to work through the inequalities together, and then you'll have the rest of the period to work, which should be about 15 minutes. It won't take us long to go through these. So the vitamin problem. Suppose you're a chief mathematician for the government's $1 million vitamin research project. So you went to college, you decided to be a statistician, and now you work for the government along with their scientists who are studying the effects of vitamin A and B on the human system. And they turn to you to analyze the information to try and help them continue to solve what they have to think about throughout the problem. So each constraint here is separated instead of it being one huge word problem. So for part A, the body can tolerate no more than 600 units a day of vitamin A and no more than 500 units a day of vitamin B. Can somebody give me 2 inequalities for that first sentence? Jacob?
A is less than or equal to 600.
Good.
B is less than or equal to 500.
Good. If you don't like using A and B, then use X and Y. Just make sure you're saying X represents vitamin A and Y represents vitamin B. So if you prefer to use X and Y, just make sure you're noting what you're using to represent the problem. Part B, the total number of units per day of the 2 vitamins must be between 400 and 1,000 inclusive. You could write that as 1 inequality, but we need to write it as 2 because it's 2 separate lines that you're graphing, which is why there's 2 spaces here. So it could be written as 1, but separate it and write it as 2. Alex, what do you think?
The first one could be x plus y have to be equal to or greater than 400.
Okay.
And then the second one could be a plus b is equal to or less than 1,000.
Good. And it's allowed to be equal to, that's the word inclusive, because it includes those values. They're part of the solution. And again, if you'd rather use an x and a y, use x and y, that's fine. Part C, due to the combined effects of the 2 vitamins, so when the 2 vitamins are in your body, the number of units per day of vitamin B must be more than half the number of units per day of vitamin A. So I'm going to stop there. What inequality would go along with that? So the number of units per day of vitamin B must be more than half the number of units per vitamin A. Kyla, you want to take a shot? Abby?
1/2 A is less than or equal to B.
And it's just actually no equal to, because it just says more than. So put a greater than sign there. Nice job. So B has to be half the number of A. So 1/2 times A. B has to be more than that. And then the second part of the sentence, it has to be less than or equal to 3 times the number of units per day of vitamin A. Abby, do you have that one as well?
A is less than or equal to B.
Good. And then the last down here, it says list the 2 obvious inequalities for the problem. Which ones do we need to include? Jacob?
A is greater than or equal to 0, B is greater than or equal to 0.
So they give us an upper bound that says it has to be less than 500, less than 400, or 600, but we need to worry about the lower part as well. You can't have negative numbers. So there are 8 inequalities here. Technically, I mean, you're really dealing with 6, because the ones on the x and the y axis, that just bounds it to the first quadrant. So if you flip the page, all of these you're going to graph on the graph or the grid provided on the next page, right down here. So you're going to graph all of them down there. The questions above then are based off of your graph. So number 2 just tells you to plot it. Don't forget to shade and label. Part 3 is write the vertices of the feasible region. And then part 4, you're going to use the vertices to come up with a minimum cost because you're paying for the vitamins. And we want to know what the minimum cost would be for those vitamins. But number 1 is the objective function. The objective function can be found or created with the fact that vitamin A costs 0.06 cents. That's not 6 cents. It's 0.06 of a penny. And then vitamin B would be 0.05 cents per unit. So what number is that actually? So what is 0.06 cents? So smaller than a penny. Chris? So what would we write that as a decimal? How many zeros do we need? How many? Actually, it's one more. So if it was 0.6 cents, then it would be 0.006. Because 6 cents is 0.06, so 0.6 would be 0.006, so 0.06 would have 3 zeros. I know that's weird. One more there. But these are vitamins, and like when you go to the grocery store, wherever you get your vitamins, you buy a vitamin, multivitamin, that actually has like 10 or 15 different vitamins in them. So if you're actually analyzing how much you're paying per vitamin, you're not going to be paying that much. You're not going to pay $1 per individual vitamin inside that pill. So that's why the numbers are so tiny there. And I wrote this one wrong again. It should be one more zero. That's my fault. There we go. All right, so grab a partner, get in a small group. You can work on any of those that you choose to work on. It's totally up to you. But please ask questions. So tomorrow I'll be able to answer some general questions, but I do want to make sure everybody has enough time to take the quiz. Okay, so I'll walk around, come help, grab a partner.
For comparison, do you know what the shade of possible? If it's greater than shade I always get those mixed up.
So, greater than, larger than, up.
Okay.
So bigger up, smaller down.
Got
Counting by 50s works very well. Counting by 50s works really well for that graph if you're working on that graph. You can count by 100s. Yeah.